So let's take a second to put everything we've learned so far together. Okay, so we've got a problem here where we've got the square root of 6 over x times the square root of 3 over x. Okay, now we know right off that we can break this up into the square root of 6 over the square root of x times the square root of 3 over the square root of x. Okay, now that we have this, then we can multiply straight across, because we talked about in the last problem that when we multiply, the things inside the root can be multiplied. And so the square root of 6 times the square root of 3 would give me the square root of 18. On the bottom, I would get the square root of x times the square root of x, which is the square root of x squared. Okay, now we can't stop here. We need to make sure that we simplify both the top and the bottom. Now it should be fairly obvious that the bottom simplifies to x, because the square root of x squared is x. Now on the top here, I need to do a little bit of thinking. The square root of 18 is the square root of 9 times 2, right? And so either I can do that, and I'm going to do it this way first. I'm going to write the square root of 9 times 2, which then I can rewrite as, because I can take the square root of 9. The square root of 9 is 3. I didn't take the square root of 2, so it needs to stay inside over x. Okay. The other way, of course, to do that is if I did the tree on 18 here. 18 is 6 times 3, and 6 is 2 times 3, which means I do have a pair of 3's here, right? 3 and 3. That pair of 3's will come out, and the 2 will stay in, leaving it as the square root of 2. And so we've simplified our problem. And this is much simpler and easier to deal with than this thing that had 2 square roots and 2 x's and a bit more complex there. Okay. Now, I want to introduce you to 2 more things. One of them is rationalizing the denominator. Okay. Now this is dealing with something like this, where I have x over the square root of 7. Okay. Now the problem with this right here is that in math we are not allowed to leave a square root on the bottom. Okay. When you can't take the square root of a number, we call it irrational. Okay. So irrational. We talked about irrationals before way at the beginning of the year, but irrational numbers do not have a perfect square root. Okay. And we're going to do what we call rationalizing the denominator. And so we're going to take the denominator and we're going to make it so it's not irrational anymore. And the way to do that is by multiplying by the square root of 7 over the square root of 7. And when I do that, I'll multiply straight across, and I'll have x root 7 over 7 times 7 is 49. Now you'll notice what this does is that it allows us to take the square root of 49, which means I now have x root 7 over 7. And since I've now taken the square root of 49, then I no longer have a square root in the bottom. And so I have rationalized the denominator. Okay, let's look at one more problem like this on this video, and then we'll save the last piece for one more video here. And so let's take one more example problem. We'll take the square root of 2 over the square root of 3b. Okay, again you'll notice we have the square root on the bottom, and so what we need to do is we need to get rid of that. We're going to multiply by the square root of 3b over the square root of 3b. Now I'm allowed to do this because this right here is 1, right? Anything divided by itself is 1, and so I'm allowed to multiply by 1, and it doesn't change my problem. It just changes what it looks like. It doesn't actually change the value, because anything times 1 is itself. So let's go ahead and multiply these, and so I'll have the root of 6b, right? Because 2 times 3 is 6. I can multiply the things inside the root, and then the b just stays. And then on the bottom, I'll have the root of 9 and b squared. Okay, and so for my last step, I'm going to simplify the bottom here. Okay, the top's going to stay the same. I can't simplify the 6 or the b. I should check, but 6 is 3 times 2. I don't have any pairs there. There's no perfect square factors. And the b I know I can't take the square root of. And so I can take the square root of the 9, and I can take the square root of the b squared. And so this right here is my final answer. Now some may ask, well, can I reduce that? No, you can't, because you cannot divide something that's inside a square root and something that is outside of the square root. Okay, you can only divide if they're similar type terms. Okay, so that's rationalizing the denominator, and we're going to do one more video with the adding and subtracting of radicals, and so you can watch that.